Okay, so let's find our first and last expected values. So what's the name of our first expected value? Daphne, what do we call that one? E what?
E1.
E1, first row,
Comma.
first column, E1, 1. Okay, so then how do we compute that one?
Like the total.
Yeah, just tell me a number to multiply. What?
108
Hmm?
and 145.
Okay, and then do what?
You divide.
By,
I'm not sure.
okay, by the grand total.
Oh, 168.
Michaela, what'd you get?
93.21.
You said 93.21?
Yeah.
Great. Alondra, what's the next one? What's the other one? E what?
230.
Yep, second row, third column, 2, 3. Nice, and that one is what?
60 times 11.
And you got 3.923?
Yeah.
Sounds good. Should make that better. Okay, good. All right, and then what everybody did was they took this part here and put it into the matrix, correct? And they did chi-squared. So you did, bless you. You did stat, test, chi-squared test, and you got chi-squared is equal to, Nicole? Or no, actually, I haven't called on Nathan lately. Nathan?
I got 3.56.
3.56? Everyone else concurs? Terrific. Okay, good. All right, now let's get to one that might be. Oh. Don't do a test, just compute the F statistic. It's an Anova problem. Again, do not test. Just compute the F stat. People are paging through their notes. How do we do this one? You do need numbers to put in the list in order to calculate the Anova. So I didn't give you numbers to put in the list. So how do you calculate the F stat? Oh. Anybody remember? Diego's like, I got this. I got this.
Oh, yeah, there is.
Oh,
Right. This is the between group variance. So this is where I told you, I talked to you folks about how I expect you to know at least the concept of the F-stat is the difference of, remember those kindergartners, the fourth graders and the seniors, right? And they're between the group variances is this, whereas they're within group variances is only that much. So the ratio of the between the group variance versus over the within group variance is your F statistic. So you just take the between group variance, divide by the within group variance, and there you have it. There you have it.
Yeah, 5.89.
So it's 14.85 divided by what?
14.85 divided by 2.52.
And you got,
5.89.
there you go. It's just that. Don't make it, don't overcomplicate it. And then, aha. So here, does a relationship exist between population and COVID deaths? So, what kind of problem is this one?
Check the 10.
I'm gonna take 15 seconds to try to figure out what kind of problem it is.
I have a question about the last problem.
Yeah.
So if you're not given if you're not given the values and stuff, you just use the group variance and stuff.
Yeah, yeah,
Okay.
exactly.
Okay.
I told you at some point in our test, just a few points, 3 points or something like that, that you understand that the F statistic comes from the between group variance ratio over the within group variance ratio.
Okay.
And the other stuff is thrown in there just to distract you. Yeah.
Will you give us will you always give us the between variance and the within?
No, I won't.
Oh, you won't?
I'm only going to give it to you if I expect you to compute the F statistic.
Oh, okay.
Otherwise, you do the whole thing like you normally do with, otherwise, you would just, right, so here's Anova. Right, means, difference of the means, everyone see this? Does everyone see difference of the means here? This is 3 means, that's an Anova. So here, you would just put the lists in, find your F-stat and your p-value. Right, this is a regular ordinary Anova problem. So I will give you a problem where you have to do the whole test. But the other one, you can't do the whole test because all I gave was just bits and pieces. I didn't give you everything. Is that making sense for folks? Okay. So here, right, okay. Now in the meantime, this is a problem. This is, and we decided that it was a linear correlation problem because it says linear correlation right here. Okay, so this is chapter 10. So you're going to do your hypothesis test on this. But then don't forget, I will probably also have you predict. Right? I'll give you an X and ask you for the Y. And then what if alpha was 0.05? Then I might give you a different alpha and ask you to figure out the now predict and check and see. That might change, right? Depending on what your alpha is, you may or may not reject H naught, and rejecting H naught changes whether you use y equals mx plus b or whether you use y equals y bar. Right? If it's a line, you use y equals mx plus b. If it's not a line, you just use the average, the sample mean, or sample proportion. Okay. Did you folks want to do one of these, or do you feel kind of okay about it? Everyone feeling okay with that? All right, so what I'm thinking is we take a look at what the last class wanted to do was they wanted to go over some chapter 7 and 8 problems. Does that seem good? Or do people want to go over chapter 6, 5, and 6 problems? We went over those already, didn't I? Last class. Binomial and stuff like that. Okay, so let's do so on our study guide for chapter 3, here's problem number 1. Should I make it a little larger? Exam 3 study guide. So everybody should have the exam 3 study guide, right, from a few weeks ago. Problem number 1, here it is. If you don't have it, just do the first 3, A, B, and I guess it's D. I meant to call it C, but that's D. It says find the confidence interval. Okay, right. Is it a mean or a proportion? How do you know that? It says mean, it says standard deviation. Okay, good deal. What's best point estimate? Yeah, the best point estimate is the sample mean, right? So this is not the sample mean. This is the standard deviation of the sample mean. Does everyone understand that? You got to read all the words. The sample mean is a recent study showed the mean was 14.3 miles. So my x bar is 14.3. Good? All right, find the margin of error. So my E is equal to my critical value times S over square root of n. So what's my critical value? I have 28 people, so my degrees of freedom is 27. And my alpha is, 95% confidence interval. 2.052 is my critical value. My S is 2.0. My N is 28. And you got 7756. 776. Good enough. All right, then that's my margin of error. Find the confidence interval. So I'm going to take my x bar and subtract my error. And I'll take my x bar and I'll add my error. So then I'll end up with 13.524 to 15.076. And then I'm going to write it so it has the same number of decimal places as my data was in. So my sample data had 14.3, one decimal place. So I would say 13.5. If you left it all like this, that's fine. I'm not going to take off for that. Technically, you should round it to one decimal place, but it's not that big. Okay, good. All right, now do number 5. Head on down to number 5. Get a reader. Nicole, read for us.
In 1980, more than 35% of cars purchased had a manual transmission. By 2007, the proportion had decreased to 7.7%. A random sample of 122 college students with cars showed that 26 of them had stickers. Estimate the true proportion of college students who drive 6 or 90% confidence.
Great. What kind of problem is this? It's a proportion, because they mentioned proportions. What else is it? Hypothesis test or confidence interval? Confidence interval, because it says estimate. Someone see that? Okay, so way long ago it was 35% were manual, and then all of a sudden it dropped to 7.7%. But I want to see what it is for college students, not everybody. So first you need to give me, I want everyone to find the best point estimate. So give me the point estimate. And I want you to give me E. And I want you to find the confidence interval. So do those 3 things. We'll give you all 1, 2, 3, 4, 5 minutes. Look at this one. What's my best point estimate? So find the sample or the selected or the surveyed. So this is it right here, random sample. 222, so we had Here, did I give you a percentage or did I give you a number of yeses? What? I gave you 26%? Number of yeses. So it's 26 yeses out of 122. And you found your percentage as 0.213? Great. All right, that's your best point estimate. So my margin of error is my critical value times the square root of p hat q hat over n. Make sure you use 3 sig figs on this. All the proportions, 3 sig figs. Do not round to 2. That's big trouble. So my critical value, 90% confidence interval, 1.645. This is Z table, easy peasy. Times 0.213 times 0.787 over 122. And y'all got what? 0.061. Great. So then my confidence interval is going to be 0.213 minus 0.061 to 0.213 plus 0.061, and that ends up being 0.152 to 0.274. Good? All right. Excellent. Now do number 6 below it. So number 6. What kind of problem is this? How do you do a hypothesis test? Well, it does not say confidence interval or estimate. That's your biggest hint. Right? Because a confidence interval will always say confidence interval or estimate.
It also doesn't appear.
Yeah, does it appear the mean is? This is saying, yeah. So there's sort of a, a question that you have to kind of compare, a comparison question. Okay, so it's a hypothesis test. Is it a proportion or a mean? How do you know? Yeah, because it gives you a list of, a list of sample. It gives you my sample of numbers. Exactly. Also, it says average. So there's 2 ways. So you're going to have to put this list into your calculator and do calc 1 bar stats to find the mean and the standard deviation. So do this one. We'll give you folks about 6 minutes. Go over it. So first things first, you need to figure out what your x bar. You put this in the calculator and find your x bar and your s. Remember, it's a sample, so don't use mu. Don't use sigma. Use s. So your x bar is what? 9.2. 9.2. 9 point what? What did you get? No, it's not. What is it?
Bar was 8.25.
8.25. Okay. What's your S? 5.06. Okay. Okay. Oh yeah, 4. We'll add a 4 on this one up. Okay. So step 1. H naught is what?
mu equals 9.2.
Yep, my claim is that mu equals 9.2, so H naught mu equals 9.2, that's my claim. So I'm going to be using the word reject later on. Okay, so if my claim is H naught, then H1 becomes the opposite of my claim. So what's H1? Mu is not equal to 9.2. Good. Step 2, find the critical value. Got my picture. This is going to be 2-tailed. So I'm going to bust out my t-table because it's a mean. My n is 8, so my degrees of freedom is going to be 8 minus 1, so it's 7. My alpha is 0.05, and it's two-tailed. So two-tailed, 0.05, 2.3, positive, negative, 2.365. What I got. Okay, so 2.365 and negative 2.365. And then I'm going to grab my find my test stat. So that's the z-score. Z-score of my sample. So my sample, let's see, it was 8.25. And I'm going to subtract my mu naught. So my mu naught is always what's in my claim. My claim is the mu naught. So I'm going to subtract my what I got from my claim and divide by s over square root of n. So 5.064 divided by square root of 8. And what did folks get for that? What was that?
Negative 0.521.
521.
531.
5.3.
Okay. So here's my middle, roughly. It's going to be on the negative side here, negative 0.531. That is definitely in the do not reject range. Yeah, it's not unusual at all. It's actually quite close to 0. So step 4,
Do not reject H naught.
right? Do not reject H naught, which means there is not enough evidence to reject claim the mean number of jobs is 9.2. Okay. All right, perfect. Okay, so last one we're going to look at is 13, I think was what I said on the study guide. So let's take a look at number 13. Go on down to there. It has been found that 85.6% of all enrolled college and university students are undergraduates. A random sample of 500 enrolled students revealed that 420 of them were undergraduates. Is there enough evidence at alpha 0.05 to conclude that the percent of enrollment undergraduates is higher in that state?
So P is always the percentage that's given.
P naught or P, yeah, it's a percentage, it's whatever's in your claim. P and mu are the things that are in your claim. The sample, what you get from your sample, that's your P hat or your X bar. So this one sounds like you're saying it's in a proportion. That's true. Did I give you P hat or did I give you the number of successes? The number of people who said yes.
You give us the numbers accepted.
Yep. Because there's no percent on there. It's not 420%. And is this a confidence interval or hypothesis test? Hypothesis test. Yep, does not say confidence interval or estimate there anywhere. And there's also a conclusion and evidence. Okay, let's take a look here. My H naught. What's my H naught? What's my claim?
P equals
and what's my claim? It's higher, right? So my H1 is,
T is larger than 1.856.
that's my claim. So I'm going to be using the word support later on. Step 2, find my critical value. My degrees of freedom is, well, it's a percentage, so it's infinity, right? So I'm going to use the Z table. So, let's see, one-tailed, higher, so it's right-tailed, and, yep, 1.645. All right, great. So then next, we're going to take a look at my test stat. So that's going to be, let's see, my proportion, 0.820, minus what I expected to get, 0.856, divided by, yeah, Q hat over N, is that right?
Not
It is P times Q over N, the square root. So the square root of P times Q over N.
PQ over N, right, what I expected to get, 0.856 times 0.144
Yeah.
divided by 500. And what do you all get for that one?
Negative 1.019.
Okay, great, yeah, that's lower than we expected to get, so definitely not higher.
How did you get 0.8
Oh, sorry, 840. You're right, it is 840. My bad, I can't do math apparently. 840. So it's negative 1.019.
Yes.
All right, great, so that means that this is going to be, yep, do not reject H not. Hey, quiet over there. Which means that there is not enough evidence to support claims that percent enrollment is higher. You can say that same or non, that's fine. All right, good. So what I would suggest you do, amongst other things, is make sure that as you look through these study guide things, make sure that you really go over them and don't just be like, oh, I remember that, or I know that one, because it's been a few months for some of these, and the last thing you want to do is make a mistake on stuff that you know, because you've forgotten it. So I would almost say, like, pick up what I call the low-hanging fruit first. Go through the stuff that you know that you really knew well, and make sure that you review it so that you get it, you refresh your mind and you got it down again, so you can at least ace that part, and then kind of move on to the stuff you know moderately well and the stuff that you find more challenging. So make sure you really get those other pieces. Yeah.
And Connect Math has practice questions. They're really good.
Nice. Good suggestion. Connect Math?
Yeah.
They
There's
have like
practice questions.
You can like go to it's like the study tab or something like that.
There's a study tab
Yeah, and you can like click through it, and they have like a
for each chapter, for each section, I think.
Yeah.
Yeah. All right. Good luck. I will see you folks